everyone, so finally we have come to the end of this 30 days of Java challenge. The whole journey has been amazing. Kudos to everyone who have been there from the day one and has watched all the videos. Thanks for all your love, support, comments, everything that you have given to me in this journey. Now, just to do this well, close it in style, this video talks about all the important questions that could be asked from you in the interviews. Go through each of these questions, watch this video till the end. This will help you crack your next Java job in style. Let's get started. We'll start now reviewing the commonly asked questions which is being asked from the collection framework. Now again repeating, this whole chapter collection framework might be a little intimidating for you if you're learning Java for the first time. So don't get bothered about this. You just go through the entire recording once, try to understand as much as you can, and then we'll move and complete our complete data structures and algorithm. Once it is done, then I'll request you people to again come back and watch this video when it makes the full sense. For those people who have already learned it once, I think this video is going to be very helpful. Let's talk about a few of the commonly asked interview questions from the Java collection framework. Let's get started. So the very first question which you see on the screen is, what is collection framework in Java and what are the advantages of the collection framework? We already saw that. We saw that with Java, I know how to write code. But just writing code in the today's modern world is not enough. Everyone is so crazy about the speed, performance, optimization. So the way to, with any form of the data that we have today, we would like to do two things. We want to have the very optimized storage and we need to have a very fast computation. And both these things, a better storage, a better computation, that happens with the help of something called as the data structures. The next remaining days, next 40 days, 45 days, typically we're going to talk a lot about these data structures and algorithm. And that will define up with our basic Java, the programming that we have learned. But every programming language, including Java, have some inherent support for these data structures, for storing the collections of the data. So the Java support or Java response to this provide the native support of the data structures like ArrayList, linked list, stack, queue, map, tree. That typically is called as the collection framework. So it's basically the group of the classes which is the native implementation of all the complex data structures which is available in java.util package. And the advantage is that when you go and make use of it, you don't have to go and define these data structures on your own. You can directly go and make use of it. Let's move to the next question. What is the difference between the array and the collection? So the array is also used to store multiple data. Collection is also used to store the multiple data. But what are the main differences and what are the advantages? Let's try to see with the help of these comparisons. One of the biggest challenge of array is that it is a fixed size, right? If you remember, array you go and define like this: int array equals to new int 5. In the beginning itself, you go and define the size of the array. Let's say that if your decision of deciding the size was not right, maybe it was too less, then you will have to end up creating a new structure, which is again time consuming and the space consuming. And if you have taken a very big number and you're not able to store that many data, there's no requirement as such, you're just losing out on the precious space, right? So one of the biggest challenges of the array is that it has a fixed size. On the other hand, when you go and make use of collection like ArrayList or the linked list, you have a dynamic size. Second challenge is that array can only go and store the data of only one time, which actually I feel is a good practice, but in the collection we have a little flexibility. If you don't use generics, if you don't provide the data types, actually you can go and store the different types of data in the same collection, which I feel is actually not a good practice, but it provides you that flexibility. It's simple. Direct access, you can go and access through the index. In the case of the collections, you can go and get through the index, and there's several methods to use it, right? Whenever you have to go and resize it, you will have to go and do it manual thing. In the case of the array, a lot of methods are available for built-in methods for the collections. If we're going to talk about the performance, arrays are slightly faster because you work at the raw level. It is very fast for the read and write, typically for accessing the element due to its continuous memory storage. Collection may be slightly less in performance compared to the raw arrays. In the table memory, array are stored in the contiguous location, so it cannot work in the fragmented memory space. In the case of the collection, say for example, if it is a linked list, right? Typically, you don't have to worry much on that how it's stored because you can go and occupy the space even in the case of the fragmented memory spaces. Arrays are best for the simple task with a known number of the elements. and normally you go and prefer the collection when you have a complex task requiring dynamic data handling. I believe you have got enough points. If this question is asked in the interview, you have enough pointers to go and explain that to the interviewer. Let's move to the next question. What are the various interfaces used in the Java collection framework? We already talked about it. Let's see that. The different type of interfaces are, one of the name is collection interface. This is at the top. Then at the next level, I have the list interface, which contains the item, ordered item. Set interface indicates all the collection of the items, which should be unique. Queue is a special type of item which follows the order first in, first out. For example, when you're waiting in the queue, it's following first in, first out. DQ is a doubly ended queue. It's the extension of the queue interface itself, and the map is an interface which helps you store data in the form of key value. The concrete implementations of the collections could be the list. Basically, the implementation list, set, and the queue. List could be the ArrayList, linked list. Set, you have the HashSet and the tree set. For the queue, you have the linked list, priority queue. For the doubly ended queue, you have the array queue and the linked list. And for the map, you have the HashMap and tree map. Now let's move to the next question. The next question number 4, it says that what is ArrayList in Java? We have already seen. ArrayList is basically the concrete implementation of a list interface. And what it typically uses, it's a kind of array which has the dynamic size. So you can keep on adding as many elements. It has a dynamic size. How do you go and define an array list in Java? Normally you have to go and say that, say for example, list. And then you have to go and provide which type it is. Let's say that I want to go and store something called as an integer. So I go and put inside here integer. And let me go and call it as my list equals to new and then array list. So this is how you go and define the array list in Java, and this is what an array list is. A more detailed code example is this. This is how you go and define it. I go and add apple, I go and add banana, I go and add orange. And if I have to go and fetch the item which I have added at any given index, I go and say the element at the 0th index will be equals to apple. I want to go and remove the element at the first index. First index it was banana, so it will go and remove banana. And after that, if I go and show that apple and orange are getting printed. Let's move to the next one. What is the difference between the collection and the collections? So the collection, in the collection, one of these is the start or the beginning of this collection framework in Java, and the another one is a utility class which has a lot of methods, like for example sort. Let's try to quickly go and deep dive the differences between them. The collection, which is without s, which is singular, right? It's an interface, and it basically represents a group of objects as a single unit. It's a part of the Java collection framework hierarchy, right? If you see everything that you see, list, array list, all of them, they fall under the category called as a collection. On the other hand, the collection with the s, if you go and see here, this is a utility class. It has the several available and useful static methods. For example, it is used for the sorting, for the searching. It's not part of the hierarchy but works with the collections. One of the useful method of that would be, say for example, collection.sort, which we have already seen, right? Since it is an interface, this collection is an interface, so it can be implemented to create the custom collection types, often confused with the collection due to the similar names, and can be implemented only provides utility functions. So this is basically an interface. This is basically a class, and which is more of like a utility class. Let's move further. Difference between the array list and linked list in the Java collection framework. So both array list and linked list, they all are extending an interface called as a list interface. So both of them are basically a linear data structure which is used to store the data in the ordered fashion. The only difference is that array list is more. When I go and talk about the array list, sir, internally array list make use of arrays only, right? And typically when you go and end up storing more number of the elements and it nears the size of the array, doubles its size, and this quality is called as the dynamic arrays. So array list is basically make use of a dynamic arrays, sir. So one of the biggest challenge of the array list or dynamic array is that, typically they have the fixed size. So in the case of array list, since it internally make use of the array which has a fixed time, whenever you're trying to do the resizing, typically that is a slow operation. That's number one. And number two, in the case of the array list, the operations like insert or delete, they are very slow, because then you will have to go and move all the elements every time the insertion or deletion happen. So typically ArrayList is not a great data structure when you have to go and store the dynamic number of elements, or you have to do a lot of insertion and deletion. On the other hand, if I go and talk about the linked list, linked list is more of like this structure, right? It comprises of the nodes, right? It comprises of the nodes. For example, this is a node 1, this is node 2, this is node 3. The first node, the first node is known as head, and the last node typically is called as the tail. And every node knows the direction of the next node. So now linked list is a little storage heavy, because every node not only contains the data but also a pointer to the next node. But this ensures that every time I have to do the insertion or I have to do the deletion, this can happen very fast, right? So that's the main difference between ArrayList and linked list. When you have to have the multiple insertion and deletion, linked list should be preferred. When you have the dynamic number of elements, then again the linked list is preferred. When you have the index-based random access, you have to do it very fast, then ArrayList makes a good data structure there. If I go and talk about the theoretical differences, ArrayList, if you can see, is a dynamic array. On the other hand, the linked list, if I go and talk about, is the W linked list take next in the previous nodes. Fast access, random access is slower. The insertion and deletion both are slower. They are these faster. We have already seen that. They have less memory overhead. They will have the more memory overhead because they need to store the pointer to the next node. Use scenario, best when you need fast access to the elements and don't often insert or remove elements in the middle. And on the other hand, when you frequently want to add or remove elements, linked list makes sense. Iteration is faster due to the better cache locality. Iteration is slower. Fair enough. Support fast random access, does not support the fast random access. So these are the main differences between the ArrayList and the linked list. Let's move to the next portion. What is the difference between the iterator and an enumeration? Now both iterator and enumeration is basically used to go and iterate over a collection. And what is the meaning of iterating over a collection? Let's say collection has 10 elements and you want to go through each of the element. Both iterator and enumeration gets you a way through which you can jump through every element of the given collection. For example, if I go and talk about iterator and enumeration, enumeration is an older concept. These days we don't go and make use of enumerations much. It has been used for the older collections like vector, hash table. These days in the modern world we don't make use of vector collection or the hash table. Iterator comparatively is a newer concept. It started with Java 1.2 and it's being used for the modern collections like ArrayList, HashSet. Now once you have an iterator object which helps you go through all the elements of the given collection, there are certain methods. For example, hasNext will go and check if the collection has more element left. The next will get you the next element of the collection. The remove will remove that element from the collection. Similarly, the enumeration has a similarly sounding methods. For example, has more elements will tell you if there are more elements. Next element will take you the next element. Now, in the case of the iterator, you have a support of removing the element during the iteration, and that's why you have the remove method. On the case of enumeration, you don't have any. Iterator is the part of the Java collection framework. Even enumeration is, but it's mostly because to maintain the backward compatibility. Modern features of the collection framework, they don't make use of enumeration. If we're going to talk about the flexibility, iterator is almost available for all the collection framework objects. Enumeration is mostly limited to the older collections. What is the priority queue in Java? Now, before I understand the priority queue, let's first of all talk about the concept called as queue in Java. Queue is a data structure, and as we make progress in the course, we have a dedicated sessions in the data structures and algorithm where we go and talk about the queue. But for now, just give me a quick refresher. The queue stands for first in, first out data structure. Or I would say last in, last out data structure. What does that mean? Let's try to imagine a situation. Let's say that your phone, let's say that you have a Samsung phone. And your phone has battery is not working or it's not starting. So what will happen? You will go to the service center. Now once you reach the service center, you find that you are not the only person. There are multiple persons who are standing so that their turn comes up and they can get their mobile phone fixed. Normally, what do you go and call it? That line in which the people are standing before their phone are getting served is called as queue, right? That's the meaning of the queue. The same meaning holds in the world of data structure also. So the person who came first, his phone will be repaired first, then the second person, then the third person. This concept where, let's say that I have a structure, I have a data, right, which I'm storing inside a structure. So the first one to enter is the first one to exit. The first one to enter is the first one which will be used. If we go and follow this order, that data structure typically is called as a queue. So for example, few of the example of this could be that, you are waiting for the lift, you are waiting to go inside the temple, right? So in all these positions where everyone has to wait for their turn to come, they have to stand in the line, and the person who came first, obviously we get the first take. That's the example of the normal queue. Then comes something called as a priority queue. Fair enough. Let's try to understand what is the meaning of the priority queue. Let's say that there is a match between India versus Pakistan, right? And it's being played in Eden Garden. Now, this is a big match, so the large number of people have gathered to watch the match. So all of them are standing in the queue, one after the one, they are entered inside the ground. Now here what happens? Here the queue data structure comes into the action, queue. The person who came first will be the first one to go inside the ground. The person who came second will be the second one to go inside the ground. But let's assume that at the same time, Mr. Mota Bhai, Mr. Ambani comes in. Do you think he will wait for you to go in and then because he came last, he will go inside the ground last? No. He will sow the heat of his money and then a special arrangement will be done for Mr. Ambani so that he can go easily and get a special seat inside the ground. This special treatment that was being given to Mr. Ambani is called as a priority queue. So in other words, there are two types of the priority queues in the world of Java or the data structure. One is called a max queue, or another one is called as a minimum queue. What it means that, let's say that I have a queue where I added elements like 3, 1, 9, 5, 6, 4. So in this case, if it is a max queue, every time I dequeue or every time I go and remove an item, since it is a max queue, always the maximum element will come out. So the first time when I go and do this, the first time it will go and return 9 and then it will be gone. Second time when I go and do the dequeue, I'll go to get the 6. And 6 is not removed from this queue itself. So this is an example of a priority queue where the elements every time you go and remove is not based on the first in first out basis, but it's based on the certain priority that you go and define. Let's move to the next question. And if I want to go talk about the example of this, priority queue is a concrete class in the Java. You go and define a priority queue, adding elements 10, 20, 15, 5, 30. This is the priority queue. When you go and print this, will print 10, 20, 15, 5, 30. This is what it will go and print. Now, if I have to go and find the element with the highest priority, since by default this is a max queue, when I go and do this pq.pool, it will go and print something called as 30. Again, if I go and do this, the next highest element is what? 20. So it will go and print 20. And after the polling, 2 elements have been removed. So the next remaining element which is left is 10, 15, and 5. Let's go to the next question. What is the difference between the list, set, and map in Java? So we're going to talk about the list, sir. List is basically an ordered collection. Ordered collection. What is the meaning of ordered collection? It means that which element was added first, which was added second, which was added last. The sequence of the addition of the elements, I am able to make it very easily with the help of the list collection. That's number one. The number one, second is the set. What is the meaning of a set collection? Set means it's a collection which only contains the unique elements are present in this collection. Set is a kind of a collection where only the unique elements are present. On the other hand, the third one, which is a map. In the map, we go and store the key value pairs. So the list, we go and set a single value in a single unidimensional way. It's used for the order collection set. Similar to the list, but the only condition that it helps to enforce is that there are only unique elements, there are no duplicates. And the third one is the map, which contains the data in the form of a key value pairs. Fair enough. So these are the three different types and three different ways. Let's try to understand with the help of the differences here. It maintains the order, it does not maintain the order, store the value in the key value formats. List allows the duplicates, it does not allow them. And map can have the duplicate values, but it cannot have the duplicate keys. Implementation, ArrayList, linked list, vector. Set is HashSet, linked HashSet, and tree set. Map could be HashMap or the tree HashMap. If I want to talk about the access, provide the indexed access. There is no concept of the indexing here. And in the case of the map, we go and access it with the help of the keys. If I'm going to talk about the performance, typically slower for contents operations in ArrayList compared to the HashSet. Generally faster. Null elements, list can have the null. Set also allows null. But the map, for the map, just go and check out. This is a question for you to understand if the map has the null allowed. Uses, list is ideal for scenarios where you need to maintain the order or the need indexed access. Set is ideal for scenarios where you need to ensure uniqueness and don't care about the order. And map is used when you need to associate unique keys with the specific values. Let's talk the list example. How do we go and define a list? So you're going to define the list of type string, then you're going to add the items into the list, and then you are printing the value of the list at the index 1, and this is how you go and iterate. This is also called as a for each loop. This is also called as a for each loop. Set example. So again, you go and define the set like this. Interface is set, and the implementation in you has set. You go and add the elements into this. As you can see, the banana has been repeated twice. But when I go and print it, it will only print apple, banana, and cherry. The last banana will not be printed because it is a duplicate entry, which the set does not allow. Same way, we are going to talk about the map. You go and define the map. Then you go and add the tuples, key value pairs. And then you can get the any value by using the keyword, using the get method. And then you can go and iterate over this map. Now, another very classic example, which is what is the difference between the queue and the stack. Now, you guys will be crystal clear as we move ahead and we go and talk about topics like data structures and algorithm. But for now, if I have to go and understand what is the meaning between the queue and the stack, the queue is the data structure we already talked about. It follows the first in, first out, or last in, last out order. On the other hand, the stack is a data structure which makes use of last in, first out, or first in, last out order. Now, if you have to go and try to find the the memorize or correlated, we have already given you the reasons. For the queue, you can think of, let's say that you go to a service center, or you are at the ticket counter, right? And then the people have standing in the queue to get service or get the tickets. Now here again, the person who comes first will get served first, then the second, and then the third. Same way, in the case of the stack, if I go and talk about, you can think of, let's say that you go to a restaurant. And in the restaurant, there's a, the plates will be kept on the top of each other's pile of the plates. But the plate which was kept first will be, and the plate which was kept last is the first one to be picked. So the order which it is following is first in, last out, or the last in, first out order. This is the main difference between the queue data structures and the stack. Now in this case, if I try to go in detail into this, queue, as you can say, is the first in, first out, last is last in, first out. In the case of the queue, the elements are added to the end. In the stack, the elements are added to the top. In the queue, the elements are removed from the front, the elements are removed from the top itself. So basically the idea is, in the case of the queue, the removal and the addition will happen from the two ends. On the other hand, in the case of the stack, both the removal and addition of the elements happens from the same end. Similarly, access to the element is generally from the front and the rear. Access to the element is generally from the top. Normally, in the case of the queue, you use a term called as NQ and DQ. NQ means that you want to go and add elements. DQ means you want to go and take out the elements. In the world of the stack, use a term called as push and pop. Push means that you want to go and insert element. Pop means you want to go and take out the elements. Then the next one is usage. Normally queue you use when you have the first in first out. Stack you use when you want to go into last in first out. Common methods are NQ, DQ, peek, push, pop. Peek means that you want to go and see the top, what is the last element or the next element to be removed. Implementation, common implementation include linked list and the array DQ. Common implementation include the stack class and the array DQ. Let's move on. What is the hash code? So hash code, this is basically a method which comes from the object class. So every class, since they go and inherently go and extend the object class, which is the parent class for all the classes, they have this method called hash code. This basically tries to go and find the hash code of the, it helps you get the hash of the given object. Normally this hash code is typically used to make a hash code and equals method contract, so that only if you go and imply this, these objects can be used in the set or hash maps. This is the ArrayList and vector in the Java collection framework. See, both ArrayList and vectors are used to go and store the multiple elements. They are the collections. Normally vector was used in the older collection framework. ArrayList is the modern day collection framework utility. Let's see with an example. ArrayList has been introduced a little later, around Java 1.2. Vector was there in 1.2 itself. ArrayList is not synchronized. What it means, if this is a multi-threaded environment, ArrayList might get you some kind of wrong results because it's not thread safe. On the other hand, vector is a thread safe. Because of the multi-threading thread safe, it will be slightly slower. On the other hand, performance of the ArrayList will be faster. If I go and say that what is the growth policy, so every time you go and reach the size of the given array, the array tries to resize itself by 50%. On the other hand, vectors has to resize itself by doubling its size. Both internally makes use of arrays only. And that's why they need to go and double or resize themselves. Default capacity of the ArrayList is in the beginning 10. Vector is also 10. Method availability, ArrayList do not have any method which is synchronized, has synchronized methods for the thread safety. Usage, preferred for the non-threaded application where performance is crucial. So if it is not a multi-threaded environment, ArrayList is one of the great choice to use it. On the other hand, vector could be used when thread safety is required and synchronization is needed. Difference between the iterator and the list iterator. Iterator and the list iterator, both has iterator in between. The commonality between both of them is that both will be used for iterating over collections. Right, so iterator and the list iterator can be used to iterate over the collections. And I'm going to talk about the list iterator, specifically used for the iterating over list, iterating over the list. Let's try to see the example. Iterator can be used with any collection. For example, iterator you can go and make use of ArrayList, HashSet. List iterator can only be used with the list. For example, it can be used with the ArrayList, it can be used with the linked list. Directional traversal is only forward traversal, one way. In the case of list iterator, I can traverse in both directions. If I go and talk about the iterator, I can only read elements. Whereas in the case of the list iterator, I can do a lot of CRUD operation. I can read, I can update, I can add elements. The methods with the iterator is the hasNext, next, remove. HasNext will go and check if it has another element left. Next will always get you the next element of the collection. Remove will remove the element. On the other hand, list iterator has the hasNext, next. It can also go back. So you have the has previous, add, and the set method. Uses, if I want to talk about uses of the iterator, used when you need to iterate through the elements without modifying the list. List iterator used when you need more control over iterations such as moving backward and updating elements. What are the features of Java HashMap? So Java HashMap, typically what it does, Java HashMap is used to go and store data in the form of a key value pair. It allows and touts that if you want to go and insert and fetch data, it will help you do in the order of one time complexity, in the constant time. Normally a hash map is defined something like this. You go and define call as map. You have to go and provide the data type of the key and the value. So I want to say that string map equals to new hash map. Okay, this is how you normally go and define the hash map. What are the collection interfaces? The different interfaces which are available in the collection frameworks based on which you go and define the things to be done. For example, you might have the interface called as a list interface. You have the interface called as a set interface, right? You have the interface called as map, right? These are all the examples of collection interface, right? So collection interface is at the top. These kind of interfaces which are there, which helps you define the contract on the different types of the collection, that's called as a collection interface. The list interface is basically a type of the interface which indicates what are the different methods a data structure like list should have. Right, this typically the list interfaces. Write a program to convert a given array into the collection with as is as a list. It is saying that you need to have an array and then you have to go and convert that into the collection. Just try to see with the help of the code example. So what we do, we first of all go and define an array. Okay, perfectly, it's defined. Then using this arrays.asList method, I go and pass this array, I go and create this array list, and then I go and print from here. So this is how the array list looks like. Difference between the HashSet, HashMap, and HashTable. Let's talk about each of them. HashSet implements the set interface. It means that it will have the unique elements. HashMap and HashTable both are the key value map. They are both key value takers. They both implement the map interface. HashSet can only store the value as already said. HashMap and HashTable can store the key value pairs. HashSet does not apply the paid values. In the case of the HashMap, keys must be unique. Values can be duplicated. Null keys or values allow one null value. HashMap allows one null key and multiple null values. HashTable does not allow null key or the null values. Thread safety, HashSet is not synchronized, not thread safe. HashMap is not synchronized, not thread safe. HashTable is synchronized and it is thread safe. Performance wise, generally faster due to the lack of synchronization. HashSet is fast. HashMap is also generally faster. HashTable is comparatively slower because of synchronization. No guaranteed order in the HashSet, no guaranteed order in the HashMap, and no guaranteed order in the HashTable. Iterator type, fail fast. HashSet is the fail fast. HashMap is fail fast. HashTable will be the fails fast. All of them are the fail fast. So sir, finally we have come to the end of this Java series. The last 30 days we have learnt a lot. I have got amazing support from you people. Let me know in comments what your entire experience has been. You are all set now to go and answer the questions which they can ask you in the Java interview. Now this is the core part. I'm all set to now bring more advanced portions of Java. And this should be followed by the data structures and algorithm. This should be followed by the Java development. And as I promised, I'll bring all these things together for free on this channel itself. Please go and tell your friends your experience of learning here. My whole goal is that even though it is YouTube, it is free, but it has to be the world's best content. I'll put more energy, I'll bring better content. Only thing that I need from your return is a little love and support. If you are able to complete this 30 days of core Java challenge, please go and tag me over the different social media handles, be it LinkedIn, be it Instagram, be it X, and let the world know. And let the world know that how magnificently you have been able to complete this course. I'll see you in the different other courses. Till then, all the best, keep rocking and moving towards the direction of being the top 1% techies.